Okay, let's talk about problem 7.9. It says that a radio wave has a frequency of 3.8 times 10 to the 10th hertz, or cycles per second. We want to know what is the energy of one photon of this radiation. So this is the computation of the energy of a photon of radiation of a given frequency. That's what this is all about. When you're faced with a problem like this, there's basically one pretty simple way to solve it, okay? You go to this equation. E, the energy of a photon, is equal to h, which is called the Planck's constant, multiplied times the frequency of the radiation of interest. So energy is directly proportional to frequency through the Planck's constant relationship, okay? So if I want to compute my E, I just need to multiply two numbers together. Fortunately, one of them I've been given in the problem. It's the frequency. 3.8 times 10 to the 10th hertz. So that's pretty simple. Okay, so that number just goes there. I only need one more number, h, which I just said was my Planck's constant. This is just a constant. It has a value of 6.62 times 10 to the minus 34 joule seconds. Hertz, if I convert that to an analogous unit, is just cycles per second, or seconds to the minus 1. So as a result, the second units are going to cancel out. This is like 1 over a second, right? Now I'm going to be left with energy units of joules, which is what I want for this particular problem. And if I do the multiplication here, quickly learn that the energy of one photon of this radiation is 2.5 times 10 to the minus 23rd joules. This is a very easy, straightforward problem. Okay, I wanted to show it to you though, because this type of problem is really easy to ask in the homework. It's really easy to ask on an exam. And it's really easy to get right? So you want to make sure that you know how to do this. Okay, this is a computation of energy of one photon of any electromagnetic radiation. Is something that you'll probably see in the future on a graded assignment. If I wanted to make this a little bit more difficult, I could have, instead of giving you a frequency, I could have given you a wavelength. But that's not too much more difficult, because then you just need to use this relationship, speed of light equals frequency times the wavelength, to figure out what the frequency is. And once you get the frequency, you can plug it in here and solve, okay? Key places you can go wrong, just make sure that the frequency is in hertz or cycles per second, not kilohertz or megahertz or anything like that. You got to go to hertz, the base unit, or cycles per second. And if you do that, you punch the numbers on your calculator, right, you should be golden.